Hey there. So today I'm going to talk to you about how to calculate growth rates for bacteria using growth curves. All right, so hopefully this will look familiar to you, right? So we have time on the x-axis and optical density on the y-axis. So optical density is just a proxy for the number of cells you've got. It's a measure of how cloudy a culture of bacteria is. What we expect to see when we're growing a batch culture of microbes is for growth to be minimal at the first. This is called lag phase. Then you'll have a period of rapid growth called log phase. Will then plateau out when the nutrients in the media run out, and that's stationary phase. Okay. So, the important thing to notice is that this area here, this part of the curve, in log phase, this is going to be a straight line, but only if we transform the data on the y-axis to be logarithmic. So what we want to do is we want to pick 2 points on this line to represent the beginning and the end of log phase, and we're going to use those to plug into the exponential growth equation, where nt is this last point, and n0 is the first point. T is the elapsed time between them, and r is the growth rate that we're trying to calculate. So I'm going to show you how to do that with a spreadsheet of growth measurement data, just like the one that you'll have from class. All right, so over here in this column, you've got the time measurements, and in this column, you have optical density measurements showing growth. The first thing we're going to do is we're going to select the very first cell in the time column. Don't pay attention to that. All right, select the first cell in the time column, and I'm going to hit Command-Shift-Down, which will select the entire column. Right? Or I can select the bottom one and say Command-Shift-Up, do the same thing from the opposite direction. Now I'm going to hold Command by itself and click on the first cell of the column that I want to make a growth curve for. Now again, Command-Shift-Down to select that whole column. All right, now I'm going to click the Insert tab, and I'm going to insert a scatter chart. This is going to make a graph showing each of the points, optical density on the y-axis and time on the x-axis. This isn't really a good example. This growth curve doesn't really look much like a growth curve. So what I can do is I can just drag and drop this blue box around any set of data or any column of data that I'm interested in. So I can kind of scan across the wells looking for some data that looks right. So that one looks better. Let's keep looking. All right, that one's starting to look pretty good, right? So we can see a definite lag phase and then exponential growth that starts to level out as it approaches stationary phase. All right, we have to set this to a logarithmic scale though, okay? Because when they're in log growth, then the graph is going to be a line on a log y-axis scale. That's what I've done here. And so we're looking for this period here where the points are all in a straight ascending line for a while. I'm just going to hover my mouse pointer over that line towards its beginning, and I can see 2 points there, the time and an optical density measurement. So I'm going to write those down in my lab notebook. Then I'm going to move my pointer farther up there. It still needs to be a straight line. That indicates they're still in log phase. And I'm going to have another time and optical density point. So I'm going to write that down too, and that will let me plug that information into the equation nt equals n0 times e to the rt. I'll solve for r, and that will tell me what the growth rate of these organisms is. So you've got 4 replicates for each of your organisms. So instead of having to do all of that for each one, all we're going to have to do is just drag that blue box around to each of your replicate wells and just repeat what I just showed you, selecting 2 time points in log phase for each one. Then you're done.